All right, so this is the video for Unit 5, Notes 5, which is sampling distribution of a difference in sample means. So just like as a brief overview, this is basically we're going to be looking at two different samples, looking at their means, and seeing if there's any sort of difference between the two. And so just to start off with, why do we even worry about this? That's because this is going to be a common practice in what we call statistical inference. And that's basically the rest of the year. We got 4 more units. It's all basically about statistical inference, okay? Basically drawing conclusions based on whatever our data suggests, okay? So in this case, we're going to be looking at 2 samples from 2 populations to see if there's a difference. Or we can look at 2 different experimental treatments and see if there's a difference in those either due to natural variation or the treatments themselves. So like maybe some medicine company is testing 2 new drugs and they're trying to figure out which one is more beneficial, that kind of thing. And like I said, these problems are all going to be looked at in the coming units. Basically, the last few units has been like this whole unit has been basically getting the numbers, then the math down for that foundation, and then we're going to actually apply it to sort of real world problems. Okay, so just as a reminder, when we're talking about sampling distributions of means, okay, we have to worry about those 3 conditions, just like we've been worried about for the last couple weeks. Shape will always be approximately normal, so long as, got 2 situations, if our sample size is less than 30, okay, and this is the one where we have to really watch out for things. If our sample size is less than 30, then we have to be sure that the population distribution is normal, okay? So if our sample size is less than 30, as long as the population is normal, then our sample will be normal, okay? And then our other one, so if n is greater than or equal to 30, okay, then we're good to go because of the central limit theorem, okay? So the central limit theorem tells us that the sampling distribution will be approximately normal. Okay, so those are 2 situations for our shape being normal. Okay, center, our sample mean is going to be equal to the population mean as long as, remember we have to worry about, we randomly select, and that's if we're doing sampling, or randomly assigned, and that's if we're dealing with an experiment. Okay, and spread is our standard deviation, and the standard deviation of our sample is going to be equal to the standard deviation over the square root of our sample size. Okay, and this we have to worry about the 10% condition, meaning that our sample size needs to be less than or equal to 10% of the population. Okay, and again, this is 10% condition, and this is again only when sampling. All right, so think back to when we did the combination of sample proportions it's been a couple weeks ago from now, but just remember we had to combine things and we had to worry about both samples, okay? So the same thing is going to occur here, okay? So we're going to have 2 different sample means. We're going to have our sample mean from the first group and our sample mean from the second group, okay? And I know I've got this sort of across 2 pages, but we're going to get through, I'm going to do shape, center, and spread, so I'm going to be going back and forth, so please bear with me. All right, so shape will always be approximately normal. Again, as long as, remember we got to do that, we have to check the conditions for both groups, okay? So this means that our sample size of sample 1 needs to be greater than or equal to 30, and sample size from sample 2 needs to be greater than or equal to 30, okay? All right, and this is if we need to use the central limit theorem, okay? But again, that's one way to check if both populations are normal, then N can be N1 and N2 can be less than 30. Okay, those are our two situations. Have to have one or the other. Okay. And then same thing for center. Our mean for group 1 is going to be equal to the population mean of group 1, and same thing for our sample for group 2. It's going to be equal to the mean of group 2. So then remember, when we're combining distributions, we're looking at mu x bar 1 minus x bar 2. It's going to be equal to mu 1 minus mu 2. And again, as long as we talked about up here, it's sampling, has to be random samples. From the population, sorry for my handwriting there, from the population, or random assignments if doing an experiment. And then last up, spread. Remember, this is the one that gets a little out of hand, so I'm just going to write it all out for once. We know x bar 1 is going to be equal to standard deviation of 1 over square root of n, 1, and standard deviation of x bar 2 is going to be equal to standard deviation 2 over square root of n2. Okay? And when we combine the standard deviations, we're really combining the variances. So we're going to have x bar 1 minus x bar 2 is equal to the square root. And remember, I'm going to be simplifying this in just a second, so just bear with me. So here is variance of 1 and variance of 2, because we had to square them. All right. And then whenever we can simplify this a little bit, because we have a lot of squareds and square roots and stuff like that. So this all ends up simplifying to just this. Because we'll have the square root of standard deviation squared of 1 over n1 plus the, standard deviation 2 squared over n2. Okay. So it's not that much better, but it is a little bit better. Okay. So if you were looking at like trying to memorize a formula, this is what you want to go with. The other one's not super important. It's just that like the first step to get there. Okay, remember for spread, we need to make sure that both samples satisfy the 10% condition. So that means that N1 needs to be less than or equal to 10% of population N1, and then N2 needs to be less than or equal to 10% of population of N2. Okay, and remember, this is only if sampling. If you're doing an experiment, there's no need to check this. Okay, so I'm going to stop this first part video, this first part of the notes here. Just make sure that I stay under 10 minutes. The next video is going to go over this example.